Okay. So am I audible? Yeah. Chandana, can you please comment whether am I audible or not? Okay, thank you. So let's wait for 2-3 more minutes. Let the others join. Then I will get started. Okay, so I am starting today's lecture. So lecture is being recorded. Yeah. So those who will join late can cover from there, and those who are not joining also. So this week, uh, the major focus was on the types of grammars and the acceptors, and basically on recursive descent parser and LL1 parser. So in the very beginning lecture, it was told that there was a man named Chomsky. He has provided four type of grammars, four type of languages. Uh, he told that there are we can differentiate between type 0, type 1, type 2, and type 3. So type 0 is called regular language. So these are actually languages. So according to these languages, there are corresponding grammars. So the grammars type 3, the corresponding grammar is called regular grammar. then there is context free grammar, there is context sensitive grammar, and then there is free grammar. So these four kinds of grammar, and from type 0 to type 3, when we move, the grammar will be more restricted. Second thing is, where there are grammars, there will be acceptors. So there are acceptors. So for type 3 grammar, there is the acceptor is called finite automata. So finite automata. Then for type 2 grammar, context free grammar, there is push down automata. Then for context sensitive grammar, we have linear bounded automata. And the more flexible part, the free language, there is no automata, there is Turing machine which can accept it, but it is hypothetical. So it is the more flexible, and as we move forward, it will get easier to implement. So now if we tell about the productions, it can use production rules. So for type 3 language, it can accept only of this type of uh, productions, uh, exterize A, exterize AY, where X and Y belongs some set of non-terminals and A belongs set of terminals. This is one thing. So there will be only X in left hand side. Then when we go to the next one, for this CFG, so here we have LHS of all productions will have only single non-terminal. So this is one thing. So it can accept like X belong AYZ or ZAY or anything else. So, and there is no restriction on right hand side. There is no restriction. The next thing is for type 1, we have every rule will have a context. Okay, like the example given on PPT is alpha x beta. If it is given uh, as production, it can provide alpha gamma beta. So what context is this telling? So I have doubt that which grammar is more flexible and popular grammar. Most flexible grammar is your type 0 grammar, free grammar. Okay, and popular means what you want to say as popular. What is popular? Uh, can you please tell which kind of popular? So uh, the means the regular grammar, if you tell about regular grammars, it is very simple to means design and accept. But if you will get from type 3 to type 0, you will have less restrictions. It can means uh, you can say it can take more kind of productions, more kind of strings flexibly, but at the same time, the creation for this acceptor, that gets more complex. So if you see, finite automata you can create easily, push down automata you can create, linear bounded automata you can create, but Turing machine is hypothetical. You may or may not create. You have to do some research for that. So if you are telling popular, then if you are telling popular in context of acceptors, then I will say regular grammar. If you are telling popular in context of means everything should be accepted, then there will be free grammar. So coming to this context sensitive part, so what we want to I want to explain that every rule will have a context. So if alpha and beta, alpha x beta, if it is given as alpha gamma beta, just a second. Okay, so there is a context added to it. If x is in between this alpha and beta, then only we can replace this x with gamma. Otherwise, we cannot replace. That is the context. The next thing is for Turing machine, it is hypothetical, but it can accept any kind of string like ABCD can derive alpha, beta, gamma, theta, any kind of language. So what restriction we have in type 3? The restriction is that we should have this only this terminal, non-terminal in left hand side. In type 2 grammar there is less restriction. We can say if we have x in that side, we can also have y in left hand side, but the rule is that LHS should have at means only one this non-terminal, either it should be x or y or anything. And for type 1 we should have context with it. Otherwise just only one restriction, that we should have context, but in Turing machine it is totally free. You can accept any kind of string, so that's why it is hypothetical. So for each kind of string you should have rules, but there is no rule likewise. So that is one thing. Then in case of parsers we use context free grammar. So for context free grammar, what I want to cover, as there is too much theory, so this is actually a problem solving session, so I am planning to cover most of the questions today. So most of the problem solving part I want to do today. That's why I am just jumping to the next one. I will just show PPTs, then I will go to this question part only. So in this week, the main thing is taught is that what is the grammar, and it is having four uh, set of things in a tuple. First is set of non-terminals, then set of terminals, then there are some production rules, then there is some special symbols. We in VN, that is we can say it as start symbol. Like here we have start symbol as E. We have a set of productions like these, and we have set of non-terminals E, T, and F, sorry, and then we have set of terminals like plus, asterisk and braces, and there is id. Okay, likewise then there are some things taught on error handling part. So in error handling, what uh, is shown that there are some errors which can occur at lexical analyzer, is like if we are given any kind of uh, typographical error, like if we are telling that our compiler should accept the strings which is having any letter starting with any word starting with any letter or underscore, but we are providing at first case if we are providing something like uh, mm, some arithmetic one or integer, so that will be an error that comes under this lexical analysis error. Then there is syntactic error, like we are given some kind of loop statement. So in C, if we are providing loop, we should have some consider for loop. So we have for within bracket, there are something, there are two commas, two colons in between, two semicolons. We have three values: initialization, then increment, then uh, how we will get out. So if there is something missing in it, like we miss let's say we miss the braces, so there will be some error. So that is syntactical error, means we have done something wrong in the syntax. Then there is semantic errors, like we have in C, we should declare the data type between providing any variable. So if we are not providing any variable, any data type of the variable, so that may cause error. That is semantic error, because like we are providing x, y, z, and x is equal to y plus z. So what can happen if we are providing y and z as character and x as integer? So based upon C compiler, traditional C compiler, it cannot add two character arrays with the resulting as this integer. So that are some semantics followed by some of the languages, and if those are not followed, there will be errors. So this kind of three kind of errors are there. Then for each kind of error, we have some kind of error handler. So error handler, basically there are four kind of error recovery strategies it can follow. First is panic mode, like we have to discard input one at time, and like there are two curly braces in between. If there is something wrong happen, we can just remove it. Then phrase level recovery, like phrase level, if there is a phrase like if then else statement. So if there is something missing, like if something then something else something. So based upon that, if there is some error, like we forgot to write then in between if and else, and if it is there in for any compiler or any language, so for that some prefix will be replaced, like we have written if some condition, then we have missed some keyword, so it will replace that keyword with the suitable keyword. Then there are some error productions, uh, uh, like these are some productions, and we can also write some productions for error. So what will happen if there will be some error that will be detected, then that will be taken care with the help of these productions only, means some other productions, some extra productions. Then there are some global corrections, like that is based upon some user defined problems. So if there is some solution p existing, and there is alternatively there is p dash is something solution, so each time we will write p through global correction, it will be just replaced by p dash. That is the thing. So that is something about error recovery which is covered in this week 4. And then there is the major part, that is context free grammars. So there are terminals, there are non-terminals, there are symbols, there is production. So terminals are something which is which don't have any production, like this on left hand side. If there are non-terminals, they can derive anything, like here expression and term is a terminal. Then there is a start symbol. It is a symbol from where the productions get started. So like expression is here is actually the start symbol, and these all are the productions which will be followed to derive any string from that grammar, with the help of that grammar. Then there are derivations. So uh, we are given productions and we want to write some string with the help of those productions, so that is actually uh, comes under the derivation part. So there are two kind of derivations here. First is rightmost, then there is leftmost derivation. So in rightmost derivation, we just uh, take the right rightmost non-terminal and we just derive uh, to the terminal. And in leftmost derivation, we just take care of the leftmost non-terminal, and with the help of that we derive it. So next thing is parse tree. Based on production, we create a tree kind of structure we can create, and that comes under this parse tree. Means we will do something like expression with the help of production, but in a tree kind of way. Ambiguity, if there are more than one parse tree, or more than one leftmost derivation, or there is more than one rightmost derivation exist for some kind of string for a grammar, then the grammar will be called as an ambiguous grammar. So then there are something told about uh, elimination of ambiguity. So there will be statement which may have two kind of productions. First is matched statement, and then else open statement. So we put some productions into matched statement, and then the other one in open statement. So I will show some example for it. And then there is left recursion, that actually provide problem for great problem for this top down parsing. So for that we have to remove left recursion wherever we are using this top down parsing. uh, Same, uh, there is also a problem called left factoring. What happens here is that if there is a production, a derives alpha beta 1, then alpha beta 2, then the compiler gets confused whether it should use first production or second production. So we just replace it with the uh, alpha a dash, and a dash will contain these beta 1 and beta 2. So we should eliminate this also. And then we have also the different thing, the top down parsing. So in this lecture there are two kind of parsings, those were covered. So first was recursive descent parsing, then there was this LL1 parsing. So in recursive descent parsing, the procedure was to take all the productions, and if it results in acceptance of this string as a function, so that comes that can be passed through recursive descent parser. Otherwise it cannot be passed. It can be done using this uh, simulation kind of diagram. And then there are some disadvantages. They have told that it is inherently a recursive parser, so it consumes a lot of memory. because the stack grows. So to remove this recursion, we use LL parser. So basically it is LL1 parser. So for this we have to first compute the first of the production, the non-terminal, and there is follow. So there are some rules for first and follow. Those are covered in the lecture. I will not cover them again. I will just go through some examples of first and follow, and then we will just create some LL1 table for this example only. So this is something which was covered in this lecture. So I will start with the parse tree, then we will evaluate some of the uh, examples using parse tree, and then I will go through the ambiguity part, how we can eliminate, and also before that I want to cover this first and follow part, that is the most important thing for the parsing. So I am starting from first and follow. Let me share the screen. So I am starting with the first and follow. We'll do some examples. Uh, so what comes under first? If we are writing first of some non-terminal or a terminal, though, then it is actually a set of terminals, or you can say terminal symbols, that begin in strings derived from some production. Okay, so for example, if we take some production rule, say, so let's consider we have production given as A derives ABC, then DEF or GHI. So what will be first of A? First of A will contain the terminals which are starting this string. So here it is A, here it is D, here it is G. All three are actually terminals. So A, D and G will be first of A. Okay. So what are the rules? If for a production rule given X derives epsilon, or you can say empty string, so what will happen? The first of A will contain epsilon. Okay, that is first rule. Or if we have some terminal, for any terminal, say it's a small t, the first of small t will be small t itself, because it doesn't derive anything. So if a string is containing it, then the string will surely be started with t only. Then if there is some production like x derives y1, y2, y3, then first of s, first of x will be first of y1. And if first of y1 is epsilon, then what will happen? The first of y2, y3. And likewise, if there are yn, it is up to yn, then we will see whether there is epsilon or not. If there is epsilon, we will move forward for next non-terminals. Okay, then there is follow. These are actually covered in week lectures. I am just revising it for the sake of completion and for make you understand if anyone has forgotten it, so that we can solve easily. So for start symbol, say it is S, the follow of S will contain dollar symbol. Okay, and for any production, uh, say this is A is gamma beta, gamma B, yeah, or we can say beta, and beta is non-terminal. So follow of beta will be follow of A. So that is one thing. And if we say for any A derives alpha, B, beta, so if there is epsilon in, epsilon belongs first of B, or you can say first of beta, then follow of B will contain follow of A. Okay, and one more thing, epsilon can be, maybe in first of any non-terminal, say Vn, but epsilon will not be there in follow of anyone, follow of anything. Okay, so these are some rules. Now coming to some questions. So I will write the productions. I want that you solve and just comment the first and follow of the non-terminal if I say. So there is A, B, D, H, B derives small c, capital C, C derives small b, capital C, or epsilon, D derives E, F, that is capital F, E derives G or epsilon, F derives F or epsilon. So for each symbol, we have to take the first and follow, first and follow. These are symbols for S, for B, for C, for D, for E, and for F. Okay, so you just please solve, and I'm solving first for S. So first for S will be, if we see S derives A, and A is actually a terminal, so any string which will follow this production will start with this A only. Okay, so first of S will contain A, and there is no epsilon and there is no other production of S, so it will contain only and only A. And similarly for B, it will always be started from C only, there is no other production, so there is C. For C, if we see here, C derives B and C, so it will get started from B, and it may be epsilon also, so it may get started with epsilon also. And then for D, what we can see, for D, first of D, First of D is containing E and F, so it will be first of EF. Now first of EF will be uh, first of E itself. If it is epsilon, then it will be first of F. So first of E will be G or epsilon. So G and epsilon will be there, and whenever we will see this epsilon, we will go to next one. So there is F. So first of F is F and epsilon. So first of F and epsilon, and then there is nothing, so epsilon will be there in first of T. Then next thing is for follow. S is actually the start symbol and it is not occurring in any of these productions, so that's why it will have dollar in this follow. Then in each case, whenever we will see for first, we will see the left hand side of the production, and we will look that from which terminal it will get started, and for follow we have to see the right hand side of the productions. So follow of this is dollar, and then uh, follow of B, we have to see the right hand side of the production where B is occurring. So B is occurring here. Let me change the color. B is occurring here, and nothing else. So follow of B will contain after B there is D, so that will be first of D. So first of D is having G and F and the epsilon. So epsilon is empty string, so it will move forward. So for epsilon it will move forward, it will get H. So H will be there. Now it is completed, it is terminal, H is terminal, so it will not go forward, and it will be the follow up B. Then for follow of C, we have to search for C in this right hand side. We have got two, first C and second C. So it is of right hand side, and after C there is nothing, so the follow of C will be follow of B only. So follow of C will contain follow of B, and from here what we are seeing, we are getting that follow of C will be follow of C only, that is also follow of B. So it will be G, F and H. So now coming to D. So D, it is occurring here only. So follow of D will be this H, because H is following D. It is very simple, and nothing. There is no D in right hand side again. Then for follow of E, E is occurring here only. So follow of E will be F, and means first of F. E will end where F get started. So first of F is containing F and epsilon. So epsilon will not be there. For if we will get epsilon, we will move forward and see that there should be follow of D for follow of E only. So follow of D is containing H. Now coming to this F, F is occurring here. So for F, follow of F will be follow of D. So that is H. So in this way we solve first and follow problems. So this is the one thing. Now coming to the next one. So consider this one. So there is a twist in it. So actually LL1 parser basically follows top-down parsing. So we have to first check for left recursion also. If there is left recursion, then we should eliminate it. So if we see um, the first production, that is fine, but in second production A derives AD, so it will fall in left recursion. That's why we have to remove it first, then we will go for first and follow. So for removing left recursion, there are some rules, like we had to check for other production, like here we have AB. We will write it like A derives small ab, then some other non-terminal we will provide it here, and for that terminal we will write the rule for this d a dash or epsilon. So to remove left recursion, say there is a derives a alpha, so what we do is actually a derives alpha a dash, and then a dash derives uh, sorry, or beta, so beta a dash and alpha a dash or epsilon. That is actually done in this case. Okay, um, so we have done it. Now for b derives b and c derives g, there is nothing for left recursion part. Now we can calculate the first and follow. For first of S, we have to see uh, how it is starting. It is starting with A only. So for first of S, we have to go for A. How A is getting started? It is getting started with this small a. So first of S will contain a small a. Then there is B, or there is nothing like epsilon in this production of A. So that is the only thing we will get as first of S. Then for first of A, we have already this production, and we have only A here. Then for A dash, we have A dash also now. For A dash, we have this D, then we have this epsilon, D and epsilon. Then for B, there is only one thing, that is small b, and for C, there is only one thing, small g. So these are the first. Then we have follow. For follow, what we have to do, we have to check for right hand side. So S is starting symbol, so dollar will be there. Let's see for other things. S is nowhere in right hand side, so dollar is the only thing we will have in our follow. Then there is for A, the follow of A will be S deriving A, and after A there is nothing like terminal or non-terminal also, so follow of A will be follow of S only, that will be dollar. Now for A dash, see there is A dash, there is A dash, so follow of A dash will be follow of A only, and follow of A dash will be follow of A dash. That is very trivial, so that will also be dollar. Now coming to B, so follow of B, B is here only. follow of B will be A dash is following B. So first of A dash will be follow of B. First of A dash is having D and epsilon. So for D we will take D, but for epsilon we will go forward and there is nothing, so we will move to A only, and follow of A will be dollar. For C there is no C in right hand side, so follow will be not applicable here. So that is the overall first and follow list. Okay, any doubt in this, Revant? Okay, so I'm moving to the next one. So I'm given a very simple question, like S derives L or small a, L derives SL dash, and L dash derives comma S L dash or epsilon. So if I go for first and follow, a symbol, so there is S, there is L, there is L dash. Now can you comment first of S? Can you try for it? This is very simple. And we have the terminals for these two, and comma A and epsilon are the only terminals we have, and for non-terminals we have these three symbols. So let me solve it. So first of S will contain, if we go for production of S we will get this. So first of S will contain open bracket, then there is A from another production, then first of L will contain first of S, so there is this one, then first of L dash is having this comma and this epsilon, so comma and epsilon will be there. Now coming to the follow, for follow of S, first thing is that it is a starting symbol, so there will be dollar for sure. Then we have to check for it, there is S in right hand side here and here. So first of S will contain the follow of S will contain the first of L dash. First of L dash in both cases, we see, will contain this comma, and for epsilon we will move forward and we will go for follow of L, and it will tell follow of L dash. So follow of L we have to compute and we have to add it here. So for follow of L, if we see, L will occur only this side, so follow of L is having only this uh, close braces, and follow of L dash is actually the follow of L only, that is also close bracket. So this way we have solved a question for this. So let me cover the big questions, previous year questions, then I will come back here. So first is language accepted by push down automata. So can you comment The answer, C. No, it's B. Push down automata is actually for type 2. Okay, so type 2 grammar is always context free. Okay, so that is one thing. And for this example, actually it is written wrongly. For the grammar given below, follow of B. Follow of B, you can say, just see this one, and this one. So for follow of B, you have to say from here and here, from these two, you can see follow of B will be follow of S, as there is no terminal or non-terminal after this B. So follow of B will be follow of S only from first two, follow of S union. From here, there is S is following B. So as S is following B, so first of S will also be in the follow of B. So first of S, what will be first of S? From here you can see A will be in first of S, B will be in first of S, and if there is epsilon, there will be capital A. So I think it is something wrong written here. Okay, epsilon, or sorry. Okay, now it's fine. So if it is epsilon, then it will again be this follow of S. No, then, so for epsilon, we will move again and we will again fall in this follow of S. So first of S is containing A and B, and for epsilon we will move again and we will get this, yeah, A, B and dollar. So follow of S will contain dollar, and first of S will contain A and B. So answer is B. Okay, for first answer is B, second answer is B. For this one, activation record for recursive programs are created in, it is very simple. For any recursive program you have to create some stack, so A will be the answer. Just keep in mind, uh, we just push on recursive stack and then pop whenever we get some operator. Then words of a language constitute, just answer for this question. No, only terminals. Actually, if you will see, the words are actually a set of strings. So the string what we will the string contains is actually the terminals only. So our ultimate goal, if we get any production, is to just generate that string. So the grammar we will have, the language we will have, will take some of the terminals, and based upon grammar, those terminals will be uh, means uh, means set of terminals will be created. That will be the words. Okay, like we are given some word ab for any language. If this is a word, then we have to follow what we say, that whether this word is means can be accepted by this language or not. Okay, so that is accepted based upon the grammar, and grammar contains the set of rules. So that's why this is only set of terminals. Then for this one, this is again written badly after SID. Is it ambiguous or not? Hmm, can we create more than one parse tree from it? I think no. Uh, if we just take a string, for example, for this, if we take e derives e plus t, then t derives t into f. Oh, I am creating parse tree, sorry. So this is one parse tree. If I want to create another parse tree for it, is it possible for us? Um, let's consider if I take e derives t, then can it happen? No. If I go for next derivation, e derives e plus t, and I just uh, derive from here, I again derive, then it will not result in this expression. And if I derive f from this t, then also it will result in id, not in t multiply f. So I think it will be unambiguous. You can check in answers, it is unambiguous is given. So it cannot create more than one parse tree for expression. You can check. I'm not sure, but in answer it is also unambiguous. And if we take this example, then also it is providing. If I say uh, id plus id plus id, what will happen? So that will create e plus e plus t, and e plus t. So that will also again will not create any kind of second parse tree. So it is unambiguous. We have taken two cases, and for these two we don't have any two parse trees. So it is unambiguous. Let's check for this one. Is it ambiguous or not? Yeah, that was not ambiguous. Now comment for this one. It's very simple to tell. You can just see this structure. If you will get any kind of string like id plus id plus id, here you can create more than one pass tree. Like from E, you got E plus E. From here you can move in both ways. Like from this E, you can move E plus E and then id, and from here you can also move in this way, E plus E. So it is ambiguous. Yeah, that's fine. This is from PPT. This is very simple one. For a context-free grammar, left-hand side of production rules should contain single non-terminal. That is the only restriction we have. Yes, fine. For this one, 11th, a grammar is ambiguous if there are not all conditions written. First, if its most leftmost and rightmost derivations are different, that is not the answer. If they will be different, then uh, we don't have means single pass tree, different pass trees. Then more than one leftmost derivations exist. Yes, this is one condition that was written. Then there is no leftmost derivation, obviously not. Then there is no rightmost derivation, obviously not. If there will be no derivations, we cannot go to string it from any production. So answer is B. So how we can say a grammar is ambiguous? We have to see whether there are more than one pass tree, or there is more than one leftmost derivation or rightmost derivation. In some books, in some literature, you can also see there is syntax tree. So if there are more than one syntax tree, then also you can say that the grammar is ambiguous. Now for this one, a grammar with production rules contain, is it having left factor? Just comment for it. Is it having left recursion? Is it having left factor? B, left recursion. Yeah. So for just explaining it, there is no problem with this one, but where is the problem? The answer is given B, C, A. So if we write what it will contain, so A is having B A or C B. So if I write it here at C A, and yes, if I write C here, so what I will contain C A or CB, but if C will contain epsilon, then what will happen? A derives AA. That will be left recursion. So that's why it is left recursive. Okay, for 13th one. For top-down parsing, left recursion removal is, it's simple, mandatory. Not needed is not a problem. Too complex is nothing. Then desirable, not desirable. We have to do. So derivation produced by a top-down parser is, just comment for it. This is the last previous year question. Yeah, leftmost. So the questions are done. Now coming to some problems. So first problem is for evaluation based on given grammar. Like we are given any grammar, and based upon that, if we want to evaluate any expression, or you can say we want to generate output, how can we get? So for example, we are given a grammar, E derives E plus T, or T is T multiply F or F, and F derives ID, and we are given an expression 5 cross 6 plus 2. So how we will go? We have to see it. So for that, first we have to generate this. So what it is? It ID plus ID multiply ID multiply ID plus ID. And correct one thing. This question, F cross T or T. That is the one thing. So I have to generate this from grammar. So how we will go? Let's see. E derives E plus T. Now from T, what we have to generate is go to the left one. So it will generate E plus T. Now we have this plus and this plus. From here we can go F and ID. From here we can go T, then F, then ID. But from here we have to generate two of the multiplication signs. So there is F cross T. F will derive only ID, and there will be F cross T. F will derive ID, T to F, F to ID. Now what we have got? We have got this. First thing we can see from this grammar is that the T is here on right hand side of this multiplication sign. So this is actually right associative. So what it is telling, if we have three, we can solve it from here also. If we have two multiplication symbols like A, B, C, so we will first choose B cross C, then A cross B cross C, and plus is actually showing E plus T. So if there is a plus, A plus B plus C, so we will first calculate A plus B, then plus C. So plus is actually left associative. So from here onwards, I have to just provide the lexemes 2, 3, 5, 6, 2. So how it will go? We are given 2 plus 3 into 5 into 6 plus 2. So first, in the very low level, we have this 5 cross 6. So 5 cross 6 will be evaluated first. Then one level above we have 3. So 3 will be evaluated again. Then we have this 2. And then at last we have this 2. So 5 6 is 30 into 3 plus 2 plus 2. 2 plus 90 plus 2. 92 plus 2, 94. So in this way, any expression is solved based upon the given grammar. So what I have done, I have created the parse tree from to means create this string with the help of these productions, and then based upon the depth, we have just went from down to top and took one by one and just perform the operations. And in alternative way, what we can do, we can just take this associativity rule and check there is which is associative to which one. And one more thing, as we go top to down, the precedence gets higher. So the precedence of this multiplication is greater than this plus. Okay, so based upon this rule also you can solve. Okay, so that is one thing. Also, if we want to create a parse tree from a given grammar for a word, so let's consider there is a question. The productions are like OP, 0p, then Q derives 0Q or 1Q or epsilon, and string or word I have to generate is 00101. So what I have to generate? I have to generate parse tree. I have to generate leftmost derivation, and if I want to generate it with the rightmost derivation, how we will do? So these are the things we have to done. So how many parse tree it will generate? Can you comment? So always keep in mind, if grammar is non-ambiguous, unambiguous, then it only generates a single parse tree. So if I go for leftmost derivation, so how we can generate? From we will start from a starting symbol. So what we will do? We will take P1Q, and we are using the leftmost derivation. So we will take the leftmost non-terminal, that is P here. So we will explore P, how we can generate the strings from P. So before 1 we have two zeros, so I can generate two zeros with the help of P. Okay, so what production we will use? 0P, 1Q. Now we have leftmost non-terminal, that is P again, so we will explore it again. 0P, 1Q. Again we are using leftmost derivation, so we will explore P. Now 0 0 is done. Can we generate 1 from P? There is no production which is having 1 with P. We have epsilon here, so we can use epsilon and skip the P here. So we are remained with 001Q. Now using leftmost derivation, leftmost non-terminal is q, so we will explore q. And what we have to generate, we are here, we have to generate 0 and then 1. So what production we can use, we can use this one. So 0 0 1 0 q. Now we have to generate 1, we can use this 0 0 1 0 1 q. And now we are done with this string. What we can do, we can take this epsilon and say we could empty it. So 0 0 1 0 1. This way we can generate the leftmost derivation from a given string. Now coming to the next part, if we are given to create this with rightmost derivation, so we will take the start symbol and its expression, and then we will explore the right one, most right non-terminal. So rightmost non-terminal is q here. Now what we can generate, we have 1 and we can generate 0 1 from here. So what production we will use, p1, we are here, we can generate 0 1 from here. So 0 q, then again we can generate 1 from here, q. Now 101 is done, we have to generate 2 zeros, that we can do with this p also. So we can finish the work of q with epsilon. Now we have remained with the rightmost symbol as p, it is the non-terminal. So what we can use, we can use 0p 101 from this, and we will explore p 0p 101, and then we are remained with 00101, and p can also derive epsilon from here. So 00101, okay, using p derives epsilon. So in this way we can generate rightmost derivation. And if we the grammar is non-ambiguous or unambiguous, so the parse tree will be unique. So how we will create this parse tree? From S we can go to p1q, and we can generate 2 zeros from p, and then p will go to epsilon, and we have to generate uh, 0 1 from q, 0 q 1 q, and then epsilon. So there is only one parse tree. This is the way a parser can create can work for this derivation. Now there is some question on ambiguity. So I will write this grammar and the word. You have to write whether it is ambiguous or not. So check for ambiguity. S derives SS, S derives P, S derives Q, and the word we have to generate is, this is string or word you can say, with the help of this um, P Q Q P. Okay, just comment whether it is ambiguous, grammar is ambiguous or not. Use this string whether it is ambiguous or not. we have different ways to prove it. Either we can create more than one parse tree with the help of this grammar for this string, or we can use derivations. So if they are more than one, then we can easily say that it is ambiguous. So if we see s derives ss, so we can how we can go, if we are taking this p, then s derives ss, then q, then s derives ss, then q, then p. Okay, if I go like this is p, then this is s derives ss, q, s derives ss, q, p. So we can infer that there are two parse trees for it. That's why it is ambiguous. Okay, there is one more thing. If we are given it is told in lecture, for ambiguity, if we want to eliminate, so if we are given associativity and the precedence, or you can say priority, or and associativity, so let's consider there is a grammar r plus r clean closure r then power then p. So and we are given a priority, like there is ab will be on highest priority, then there is power symbol, then there is clean closure, then there is plus, and we are given both are left associative. So what we can do, we can just change the non-terminals and bring up some rule which can result in some alternative grammar for it, which will be non-ambiguous. So as we know, uh, priority of plus is mostly less, very less, and then it is minimum priority, then this one, then this one, then a and b. Okay, a b are on same priority, and this is actually left associative. So if we go for if we write it like, if we provide e as non-terminal for this plus, then it is left associative. We have to provide e at left of the symbol, and then right should be on right we have to provide a different symbol, say t, and for t it is also left associative, so t derives t, then we can provide f, then there is f. Okay, now for this similar kind of symbols we can provide and bypass, like from e we can directly go to t, from t we can directly go to f, and for f we can directly go to g, and g can derive a or b. So that's a simple way to create an alternative grammar which is non-ambiguous or unambiguous. Okay, so this is for unambiguity. Now coming to some questions of left factoring. So in left factoring, what happens is that we have provided some symbols which are similar in all the productions for any non-terminal. So what we can do, we can take these as common, and we write a different production for dealing with this. For example, if we are given some production is like IETS, then there is A, and E derives B. So what I can see from here, IETS and this IETS are common. So when we go to compiler for these productions, what compiler will see that compiler will be confused whether to go for this production or for this production. So that's why what we can do, what compiler can do, that it can take uh, these two productions, these two set of symbols as common, and we will feed it to another symbol. So for that, if I write it like IETS S dash or A, because there is no common things between these two production and this A. Then for S dash we feed the different different symbols which are there in productions after this common one. So for this one there is nothing remained after this S, so that will be epsilon. For this one we have ES, and it is done. For E there is no left factoring, so we are done with it. Okay. For example, if let's do some better example for it. um, let's consider we are given something like this: S derives A, or AB, or ABC, or ABCD. So how we can deal with this? So in this case, what we can do, we can go stepwise. Like we will take one common, like there is A common in all these productions. We will take A outside and provide other productions in other set of symbols in another non-terminal. So S will be A S dash. Okay. Now what S dash will contain? S dash will contain, from here it will be epsilon, from here it will be B, from here it will be BC, from here it will be BCD. Okay. Now what we can do, we are remained with this B, BC and BCD. We can again take B common. Okay. So for S dash, what we can write it as uh, B S double dash or epsilon. Now what S double dash will contain? S double dash will contain, from here it will be epsilon, from here it will be C, from here it will be CD. Again there is left factoring, because there is C and C, we have to eliminate it. So what we will do, we will convert it from S double dash will be C S triple dash and epsilon. Now S triple dash will contain epsilon and D from here. Okay. So what will be the last grammar we will get from here? We will get S derives A S dash, S dash derives this one, B S double dash or epsilon, then S double dash derives this C S triple dash or epsilon, and S triple dash derives D or triple or epsilon. So how many left factoring factors will be there? How many symbols are common? We have to just eliminate them likewise. Okay, so this is one thing. Now we haven't done anything on left recursion, so I think we have to do for it also. So there is one question for left recursion I will take. So for left recursion, okay, so consider this one. A derives B small a small a or small c, B bb ab or D. So we have to check for left recursion, direct and indirect, and then we have to remove it. So what we can do, mm, from left recursion you can see for first production there is A derives AA, so that is one thing. So first let me remove this from here. So what will be there? Um, there is uh, A derives BA A dash, C A dash, and A dash will derive small a dash or epsilon, like that is told in the class. So the remained set of productions, what is right hand side, then there will be A dash, and A dash will derive the remained one like A, and then A dash, and then epsilon. So from here what we are remained with, we are remained with this production and this B. Now coming to the next one, what we can see, we can transform the B with the help of these two productions. Okay, so what B will be remain, B will be BB. Now if we see there is D also, then there is AB. Now from A, how can we infer whether it is indirect recursion or not? From A, if we put this these productions in this A, what we will remain with? We will get B A dash B. Okay, then there will be C A dash B, then there will be D. D is I have already mentioned. So we are remained with this thing. Now at final what we have, A derives B A dash or C A dash, A dash derives A dash or epsilon. Then we have left recursion on this BB and this BA. What we can do, we can just eliminate it simply. We have C A dash B B dash, and we have D also, so D B dash. And what B dash will cover? B dash will cover the symbol after this B. So B B dash, then we have this one, so A dash B dash, and third is epsilon. So this is actually the final grammar we will get after left recursion. No left recursion, no. So this is how we can check for recursion and get rid of it. So there are some more questions we can do for first and follow, as we have 23 minutes remain. So consider this one. S derives AA, AB, BB, BA, A derives epsilon, B derives epsilon. So for this, if I tell to just comment for first and follow, S, A and B, what will be there? For first, first of S will be first of A, and A is epsilon. So if A is epsilon, we will go to next one, that is small a. Now we have we are done with it, because first of A is always will be A because it is a terminal. Now coming to next production, for B we have first of B, first of S will be first of B, but it is epsilon, so we will go to B. Now B is, it is done. For first of A there is only one production, epsilon. First of B there will be epsilon. Now coming to the follow, for follow we have S is a starting symbol and it is not lying anywhere in right hand side, so the follow will be only dollar. Coming to the next one, the follow of this A. So A is followed by A here and B here, so A B will be there, and follow of B will be from here it is B, from here it is A, so A B again. It is very simple one to check for first and follow. Now there is yeah, P and A. Fine. Think it may be the last question or second last question for today's evening. Uh, we are given this one, A, C, B. C small b, B capital B small a, and capital A is given D A B C. B is given as G or epsilon, C is given as H or epsilon. So we have to first comment for first only. First of S, first of A, first of B, first of C. Okay. So first and follow. Make it more genuine. So what will be the first of this S? I request everyone to please join on time. So this video will be uploaded, but the session should be interactive, and only one person is joining for interaction, and rest others are just taking it for video lectures. So that will result in again for 2.5 hour video lectures only. So there will be no interaction. So what will be the helpful for being this solving session and this session being interactive? So there should be interaction. Okay. So first of S will be first of A from here. First of A will be first of D and first of B. So let's go one by one. First of A, what it will contain? First of A will contain first of D and first of B. So first of B will contain G and epsilon. Okay. And if it will be epsilon, we will go to C. So first of C will be H and epsilon. Now, so first of A will be D, G, H and epsilon. Now coming to first of S, what will be the first of S? First of S will be first of A. So first of A will be D, G, H, and when it will be epsilon, it will go to C. So first of C will be H and epsilon. It will be epsilon, it will go to B. So first of B is G and epsilon. Okay. And from here, from this production only. Now from here onwards, for second production, first of C will be H and epsilon, and if it will be epsilon, it will go to B, and B is terminal, so B will be there in first of S. So it is done. Now in next one, first of S will be first of B. First of B is G and epsilon, so G is there. If it will be epsilon, it will go to A. So now it's done. Now coming to the follow symbols. S is the starting symbol, so follow will be containing dollar also, and it is not anywhere in right hand side, so there will be no other follow symbols for this one. Okay, I think it is somehow corrupted. Let me join it again. Okay, so now coming to the follow of A. So we have to search for A in right hand side. So A is there, only there. So first of A, follow of A will contain first of C, because C is following A. So first of C is containing H and epsilon. If it will be epsilon, it will go to B. So first of B will contain G and epsilon. Now it is epsilon, so it will go again to S. So follow of S will be follow of A, that is dollar. Okay, so GH and dollar. And then coming to B, so we have to search for B here in right hand side. So there are 4 B's. From first 2 B's, we can say the follow of B will be follow of S, as it is the right symbol, uh, most right symbol, end symbol. And from this one we can say the follow of B is actually A, because A is following B here. Then there is B followed by C. So for C, first of C will be the follow of B, so H will be there. Now if it is H, is if it is epsilon, then it will be the last symbol, so follow of A will be follow of B, so there will be G and epsilon also. Okay, good. So coming to the next one, follow of C. What will be the follow of C? C is here. Let me change the color. C is here. C is here. C is here. So from here, C follow of C will be follow of A. Follow of A is H, G, and dollar. From here, follow of C will be uh, first of B. So first of B is containing G, and epsilon will take me to follow of S, that is dollar. So both are here. Now coming to next one, there is C, after that there is B. So B will be there. So G, dollar, H, and B. So these are the final one. So that's how we can solve any kind of first and follow kind of problems. So if any pages remained, I think my pages are also done. You can also, there are 10 minutes left, so you can also try for one more question. It is given in the slide also. Let's see. We are given this expression plus terminal factor derives E or ID. So how we will do, we will first check for the left recursion. So it is actually left recursive. Okay, so we will first eliminate the left recursion, then we will go for solving first and for first and follow. So how we will eliminate, we will check for the next production which is not having left recursion. So E will derive this one T, then E dash, then E dash will derive the rest one, that is plus TE dash and epsilon. Similarly for T derives FT dash, and T dash derives asterisk F T dash or epsilon. F derives E or ID, that did not have any kind of left recursion. So we will do first and follow for this production, and the first and follow for this production is actually given in the slides uh, in weekly lectures, so you can go it from there. So these are the things. So I think there are, so 10 minutes left. Let me solve some left recursion questions. So consider there are some questions for left recursion. Okay, so let's there is A, B, D, A or A, B derives B, E or B. How we can remove left recursion? We can check for this occurrence of the same symbols uh, in both side of the arrow, and those should be non-terminals, obviously non-terminals. So what will happen? A will derive the symbol which is not having left recursion, so A, then the another non-terminal symbol. You can write it like A dash or any other alphabet or capital letter. Okay, so that is one thing. Then there is for A dash, what we will do, A dash will contain the remaining one, like here BD, then A dash, then there is A dash, then there should be epsilon. Similarly for B dash, then there will be B dash, which will contain EB dash or epsilon. Okay, so this is a simple one. Then let's consider another case. E derives E plus E, or E multiply E or B. So what will happen? We'll do it like B E dash, then E dash will contain plus E dash, or star E dash or epsilon. It is very simple one. Then there is if there is given like, so how we will do? So there is no problem with this first one, we have problem with the second one, so that will be likewise. And what will happen to this L? It will take S, then L dash, then L dash will contain comma S L dash or epsilon, this way. Or for another question, if I want to solve like this, fourth one, let me change some symbols. T derives T0, T1, T, or 0, 1. T derives 0, 1, P. Something wrong. Okay, consider this only. So how we will do? We have this one and this one, so there is left recursion by default. So what we will infer? We will go by deriving T dash, then T dash will derive 0, T, 1, T, T dash or epsilon. So this is one thing. And I check for some other examples which we can try in this 5 minutes. So today very less people have joined on time. I think one, Revant was there from uh, starting of the class. Two people left in between class. So I request everyone to join on time. This lecture will surely be uploaded on YouTube, but the interaction what we want from your side, that will not be done. So problems what you want to take to me, that I can't take through only comments. Okay. So The solving session is also a discussion forum kind. So okay, let's do this last question. We have given this one. A derives. This is the fifth question. Sorry. A derives AC, ST, and epsilon. So what we will go with, just see, in first one there is nothing like left recursion, so that will be V only. Now coming to the next one, what will happen? A derives AC, that is also left recursion, but if you will check clearly, carefully, so SD will result in AAD or BD, then epsilon. Okay, so coming from top to down, what we will get? Now we have two things which are having left recursion. So what we will do, we will take the first as it is, A or B, then from here what we can tell, A will derive with these two, so BD, A dash, and from epsilon there will be nothing, so there will be A dash. And now what A dash will derive? A dash will derive the remaining one, AD, A dash, there is C, A dash, then there will be epsilon. So that will be the these three will be in the last round. Okay, so thank you. That is all from my side today. Uh, Thank you especially for Revant. You have joined me throughout the session. Uh, so today my focus was to cover most of the problems, but there are no people due to I don't know which reason. So today what I have covered is mostly the problem solving part for LL1 parser, ambiguity, then left recursion and left factoring. How we will solve the questions if we will get any kind of questions for related to these one. Okay, so first I covered this Chomsky form of language and their corresponding grammar. Then uh, I told something about first and follow. You can see in the video lecture. Then there are some questions I have done on first and follow. Then I solved one question using derivation, how associativity and the derivation and parse tree actually affects the evaluation of the any equation if we provide to the compiler. And then there was how we create parse tree, how we do the derivations, how we do leftmost derivation, how we do rightmost. Then I have done some questions on left factoring and left recursion, and also to check ambiguity, how can we proceed and how can we eliminate ambiguity if we are given some associativity or some priority. Then previous year questions, those were mostly based upon PPT. Okay, then in last I went through some more questions as there were some time remained for left recursion. So that's all from my side. Thank you. Please join on next Tuesday 7 to 9. I request everyone to join on time. Thanks everyone. So ending this call. Thank you, Revant.